Hello everybody, my name is Abdel-Hamid Muhammad. Today we are going to talk about IPv6. As our title is written also IPv6, the next generation internet protocol. So our contents will be like this. First of all, we are going to talk about what is an IP address and how does it work. In order to understand IPv6, we should first understand IPv4. That's why our second subtitle will be about IPv4. Then we are going to talk about IPv6, and finally we'll end up with this question: why should we implement IPv6? So what is an IP address or internet protocol address? Well, usually people recognize each other by their names, and sometimes ID numbers are used to identify persons. Let's say, for example, at Cardiff University, every student has their own student ID number, and this number is unique for every student. It is used for many purposes, for giving grades and so on. So it is also similar for machines. Every device that is connected in a network should have what we can call a unique IP address, as well as the network devices which are used to interconnect two or more networks. So for example, if this computer wants to communicate with this server, it basically uses the server's IP address. So people are familiar with names, but machines use IP addresses to talk. So this is what is about an IP address. In order to assign IP addresses to devices, firstly, the IPv4 or Internet Protocol version 4 was invented. It was invented in 1970s. It is 32-bit, and its form is like this. We have x by x by x by x, and each x is a range of number between 0 and 255, and it is also 8-bit. So in total we'll have 2 to the 32, which is approximately 4.3 billion IPv4 addresses or Internet Protocol version 4 addresses. So here we have an example of an IPv4 address. But there is a problem. People didn't think that the internet will be like today. The internet was just used for by some governments and big companies or maybe big universities. But today almost every device, every electronic device that we use is connected to the internet, and now more than 30 billion IoT devices are connected to the internet, and there could be also about 500 devices in each home that will be connected to the internet by 2022. So regarding to this huge number of devices that will be connected in the future, are the 4.3 billion IPv4 addresses will be enough for these devices to be connected without having any problem? So we should have a model of an IP address that will be sufficient for every device to be connected without having any problem of addressing. So for that reason, people came up with the idea of IPv6. So IPv6 or Internet Protocol version 6 was developed in 1998 by the Internet Engineering Task Force or IETF. It is 128-bit compared to IPv4, which is just 32-bit. So its form is like this. We have 8 group of 4 hexadecimal digits, and every hexadecimal digit is 4-bit. So in total we'll have 2 to the 128, which is equal to 3.4 times 10 to the 38 IPv6 addresses. So here we have an example of an IPv6 addresses. We should also note that the two protocols IPv4 and IPv6 are not designed to be interoperable, which means direct communication between them is impossible. But however, several transition mechanisms have been designed to rectify this problem. So we have here a question: why should we implement IPv6? As we have already mentioned about the exhaustion of IPv4, because we have just 4.3 billion IPv4 available. So basically the IPv6 was designed to overcome the exhaustion of the IPv4 addresses. That's why here we have the first benefit of IPv6. Next, IPv6 was not just convinced to overcome the exhaustion of the IPv4 addresses, but also it is to improve quality of service and improving the security also, because IPv6 provides integral support for privacy, authentication, and data integrity measures. Not just these two things, but also IPv6 provide mobility. Mobile computers are assigned with at least two IPv6 addresses. One, the home address, which is permanent, and the other is the link local address used temporarily. And also IPv6 provides us to what we can call here auto configuration. IPv6 adds concept of dynamic assignment of part of the address space based on geographic and topographic features of a given physical connection. And also when we implement IPv6, we will not need what we can call here the NAT or network address translator, which is used in IPv4 to translate a private IPv4 addresses to a public, mostly public addresses, because we don't have enough public addresses, IPv4 addresses. So that's why sometimes in a small network they use a NAT or network address translator to translate their private IP to a public IP. And so if you implement this, we'll not need the NAT also. So this is all what we can say about IPv6. So thank you for watching, and see you the next time.